Hi and welcome to a new video. This is Mohammed Ashur and I'm working as Managing Data Analyst. In this video, I want to showcase a cost prediction app that I have built. I want to explain also the narrative behind it and making some sort of like a deep dive and a walk through the application itself. So let's start with where we are today concerning the construction industry. So the construction companies, they're dealing with a wide variety of construction projects which contain a plethora of information and lots of data that come day in, day out. The data could be related to costs, time, risk, and a wide variety of other types of data. But I'm just going to focus on the cost data for the time being, which are stored mainly in spreadsheets in addition to other data storage solutions. So normally you would have four types of analysis. The first one is descriptive, which lists or describes what happened in the past. The diagnostic analytics, which explains why something happened in the past. And then the predictive analytics, having sort of a look ahead in the future. And the prescriptive, meaning how to influence the circumstances to make something happen. The majority of construction companies are stuck in the descriptive and diagnostic analytics, where we have quite a lot of information stored on databases or on spreadsheets, and normally Power BI or Excel are used to undertake the analysis of this data. But then when you try to move forward to predictive analytics, that's where a programming language is going to be needed. Definitely Power BI has the capacity or the capability to embed Python and R code inside of it, but it definitely has a substantial amount of limitations. That's why if you want to create a solution in the predictive analytics, you will have to rely mainly on a programming language. So in my mind, when I was creating this app, I had crafted a tiny process in place. So starting with loading the training data and then pre-processing the training data, making sure to understand what are the outliers using statistical methods, and then training chosen machine learning models and discarding any sort of outliers if required, in addition to adjusting the hyperparameters of these models, and then undertake the prediction using whichever models you have chosen on a single project or on a batch of chosen projects. And then last but not the least, you can export and you can visualize the end results, taking into account the different coefficients, the feature importance, and other stuff as well. So the app itself is composed of a wide variety of them files. So that is related to the architecture of the app, which we're going to be diving in later videos. This video is just to showcase the app itself, and I haven't created it to win awards. It's just to make it work and to make it deliver actual results. So the app itself, it starts with an overarching Python file, which is the orchestrator between a substantial amount of other Python files. The first one is batch processor, which aims at slicing the data into chunks that can be managed by the machine learning model itself, and then the configuration or config.py, where you have a substantial amount of hyperparameters that you can change and tweak according to the needs. And then you would have the data validator, which inspects the data and its quality, and it helps to improve the quality of the imported training data. And then there's also the debugging prediction, and this tests the prediction pipeline using sample data to make sure that everything is working in the back end, and also showcase in terminal if there are any problems to be able to troubleshoot properly. Another file is installation or install.py, which installs all the Python dependencies and ensure that all components work. And as an overarching piece of information, all the processes and all the steps that you're undertaking inside the application, you will find a feedback on terminal, so that if there's a problem that happens, you can troubleshoot it. The model evaluator, and that's quite important to understand which model works best for your use case. The project estimating application itself, the main app, which includes a wide variety of capabilities and functionalities. And last but not the least, the requirement.txt, which includes all the Python libraries that are required to be installed in the install.py. And now let's dive in the app itself. And the app, as it stands now, is still in development stage. So I have made substantial progress in terms of the back end and the front end, but I wasn't really bothered to create a batch file or a PowerShell file, which is going to make it much easier for the end user to run. But this can be an area of improvement in future releases, and I'm going to make sure to include all the links to the GitHub repository, which contains all of the Python files, the end user license agreement, in addition to a detailed report about the app itself and why it was created in the first place. So when you clone the GitHub repository, you will find a substantial amount of Python files in place. And then you can run the app itself by clicking on the run_app.py, and you'll find quite a detailed explanation inside the code itself. And you can read it and digest it at your own pace to be able to maintain the app and also improve it in the future. And then you can press on play. It's going to install all the dependencies in the background itself. And then you'll be greeted with the app, as you could see. So there are multiple tabs in this app: the data and pre-processing, the models themselves, the predictions, the outliers, and the visualizations. So starting with the data pre-processing, you'll be able to upload whichever data you want, and then you can specify how much of the data is going to be used for training and how much of the data is going to be used for testing. And you'll be able to include the outliers or remove all the outliers or do something smart. The smart keeps all the data for the decision tree based models such as random forest and extra trees, and it deletes the outliers or removes the outliers for the linear regression. And then you can press on process the data. I'm going to be doing that in a little bit. The models and training, it includes a substantial amount of machine learning models that you can choose, and then you will be able to see the result of the training in the preview window after you press on train models. And you can judge for yourself which model is going to be working best for you before undertaking the predictions. In the predictions tab, you'll have two options. If you want to do a prediction for a single project or a single line item, you can use manual input. I would advise to use a batch prediction where you can upload an Excel sheet which contains the same parameters and only the last parameter required to be predicted. One of the caveats that need to be told about this app is that it supports the single output regression, not multi-output regression at the time being. That is one of the areas which I could work on in future releases. And also this app is quite flexible, so you can undertake the prediction for costs, time, risk, whatever it is. The only thing that I can say about this is I have made it with the cost data in mind. The prediction can work normally for any other types of data, but make sure that you change in the source code itself the format of the predicted data to be in your preferred format. My preferred format was pound sterling and currency format. Your preferred format might be different from my preferred format. And then you have the outliers. That's where the specific data that are regarded as outliers using statistical methods such as the interquartile and the first and the third quartile. The relationship between these three, it can help you to understand the outliers within your dataset. And then last but not the least, the visualizations tab, which contains a wide variety of buttons, one for the feature importance to understand what is the significance of each and every single feature or parameter for the machine learning. And that is quite important to understand. For example, if you're making a prediction for a bridge, is the width more important or is the length more important in this predictive analysis? The correlation as well between the different parameters, in addition to a scatter plots, which we're going to be showcasing in a little bit, and the residual plots. The scatter plots are mainly important to understand the coefficient in the regression analysis or the predictive analysis itself. And that's going to be quite important if you want to export them to do basic Excel monitoring or analysis. So let's start with a live example. Let's load dataset, and then let's keep all the data for the time being, and then process the data. It processed successfully, and you'll also see here in the back end, the debugging is done in VS Code terminal. And I've just left it at 80/20 for the time being. You can change it however you see fit. And then for the model training, I'm not going to choose linear regression. Based on my usage, I'm going to be using the random forest, XGBoost, and extra trees. And these are the hyperparameters. I'll just leave them as is. I've tried multiple ones. The default, they work beautifully. And then I'm going to be training the models. So the models are trained. So the R squared for the random forest is about 84%. The XGBoost is about 69%. And the extra trees is about 92%, which is very good and very reliable. XGBoost, probably I'm not going to use it. So I can discard it and let me choose another one, such as the decision tree, and then I'm going to train again. So you will see that the extra tree is still at 92, that one is at 31. So that means it's not the best. Let me try to change the depth here to be 100, and let me train again the model. So it didn't really impact the accuracy that much. So I can discard it and just focus on the extra trees and the forest. And then I can go to the predictions. I'm going to use the batch. I'm going to be loading the batch file. I have one in place, so let me upload it. So data is uploaded, as you can see here, and you can visualize the different fields. the estimate at completion, which is the cost, is nil. That is the one that we want to have the predictions for, and then you can predict the batch. So successful prediction. One of the things that I have also added here is that it is going to give you sort of a range, because normally the predicted value is never going to be the true predicted value. There's a range, a lower bound and an upper bound. And let me export the results. Let me export them and call them trial, for example. And then when I open these files, you'll find that you have here the different assets or the different projects, whatever they are, and then you have the different values, the EAC, which we want to predict. So you'll find the random forest prediction, the lower bound, the upper bound, and also the confidence interval, because that's going to be different from one model to another. And that's based on a formula that you will find it here in the third tab, because this Excel sheet is composed of multiple tabs. The first one, which contains all the predictions. The second one is the model performance summary. So which model performs best and which model performs worst. So you'd find here that extra trees is the best one. The decision tree, which we have chosen, is the worst. And also the confidence interval methodology. So you'll find that the formula itself is well documented for people to understand how the reliability calculation was undertaken. And that's basically it. So that's how you can use the app in order to undertake the predictions. Before ending this video, you can see the outliers here. We haven't yet discarded any of the outliers, but you can go here and then remove all the data and then process them. And then here in the outliers tab, you'll find which data sets were the outliers. Definitely there can be some improvement to include the name of the project. I can work on that on future releases. And the last tab is about the visualizations. So starting with the feature importance, it's going to show you the importance of each and every single parameter for each and every single model, the random forest, the extra trees, decision tree. Decision tree is so bad, so we can discard it from the analysis easily. And then you can also see the correlation matrix, where that is the correlation between each and every single parameter. You can also see the scatter plots for the different parameters and the coefficients themselves. So y is equal to mx plus c. And that is quite important if you want to build an overall equation for the prediction itself. And then the last tab within the visualizations is the residual plots, and it shows you the residual points after undertaking all the calculations. And that's basically it for this application. And I wish you all the best. And if you have any queries, do not hesitate to reach out to me. And that is all for this app and this video. And do not hesitate to reach out to me via LinkedIn and also via email. I'm going to be putting the communication channels with the description of this video. Do not hesitate to visit my LinkedIn profile, and also do not hesitate to visit the APC Mastery Path YouTube channel and subscribe to it. And in future videos, I'm going to be making a deep dive into each and every single one of these files that we have explained briefly in the presentation. So stay tuned for that. Thanks a lot for watching, and catch you in the next video.